Hello and welcome to this discussion regarding number systems. This should be our module number 5, which talks about numbering systems, which are important when we are doing computer networking or when we are trying to assign different nodes on the network their identification so that they can be uniquely identified on the network. So that is why it is very important for us to understand numbering systems. So welcome and let us move together. So when you talk of a number system, what exactly does it mean? And by definition, the number system or the numeral system, it is a system of naming or representing numbers. That is what it is. And when we talk of a number is a mathematical value. Number is a mathematical value that helps to count or measure objects. That is what a number is. So at the end of the day, it will help in performing various mathematical calculations. So that is basically what a number system is. And so, like we will see, a number system is going to be a system of writing to express numbers, writing to express numbers, or the mathematical notation for representing numbers of a given set by using digits or other symbols in a consistent manner. So that is what a number system, especially in mathematical representation, is all about. So it will provide a unique representation. So it needs to provide a unique representation of every number, and it represents the arithmetic and algebraic structure of figures. And most likely you will realize that any value or the value of any digit in the number system is going to be determined or can be determined by, there will be several things, one of them being the digit itself, then its position in the number system, then the base of the number system, the base of the number system. So those are the three things which are going to determine how the numbering system is going to be like. And so the other thing we need to understand is what is the number itself. And we normally say a number is a mathematical value used for counting or measuring or labeling objects. That is how you can define a number. And it is used, the number is used for performing arithmetic calculations. So that is how you can have numbers being defined. They are of different types. You can find numbers being referred to as natural numbers. You can find numbers being referred to as whole numbers. You can find others being called rational and others irrational numbers. So all of those are labels also being given to numbers. And so that is the basis of this discussion which we want to understand the number systems. And like we have said, numbers can be used as a method or format which is used for denoting a numeric value, and there is the numbering system in which numbers are ordered in terms of symbols. You begin from 0 to 9, and this is the first type of numbering system which we normally refer to as the decimal numbering system. So in this decimal numbering system, if we can use it, and most likely you will find that the decimal numbering system, like we have said, the three aspects of the number is that you will find there is the digit itself, a digit like 0, a digit like 1. So there are 10 digits in this particular numbering system, and that is why it is called the decimal, because there are 10 unique digits from 0 to 9. And then there is also going to be the positional value from position 0 to position 1 up to 9. So that is an aspect which we need to understand, where we are talking about the position of the number in the numbering system. And then the base. The base refers to the total number of digits. So here we are talking about 10 possible digits. So the base of this numbering system is going to be base 10. So basically, in simple terms, the base or the radix is going to be base 10. So that is very important to understand. So a decimal number system will have 10 digits, and hexadecimal, because we have several types of number systems. Like for example, types, we could talk of the decimal, which we have said it has 10 digits. We have the binary numbering system, which has 2. We also have the octal, which has 8, and we have the hexadecimal numbering system, which has 16 digits. So when we are talking of the decimal number system, it is base 10 because there are 10 such digits in the number system. Binary, it is only 2 digits, so it is base 2, or the radix is 2. Then octal number system, we are going to have 8 digits, so it is going to be base 8, or the radix is 8. and then the hexadecimal number system is going to be base 16 because it has 16 digits in the whole number system. So that is very important to understand when we are talking about here. The weighting, which we have talked about in terms of position, the weighting which we are discussing here, it is the positional value of each digit in the number system. So if we took a number like this one, which is 3125, it can be written like this, meaning that from this position, this is the ones position, this is going to be the tens position, the 1 here is the hundredth position, and the 3 is the thousandth position. So it can be written the same way as this, whereby we are talking about 5 times the ones position plus 2 times the tenth position, and then 1 in the hundredth position, and 3 in the thousandth position, meaning that this could be to the power of 1, the power of 2, 3, 4. That is what we mean, because in the thousandth position, these are 4 digits. So that is very important to understand, and these have been listed here. So if we come to the decimal numbering system, we normally say that it contains 10 digits starting from 0 to 9, and it has 10 as its base, and like we have said, it is because there are 10 such digits. So if you have a number like 246.45, this value is formed by each digit, which can be multiplied by the base in the power of digit position. That is why we are multiplying 5 multiplied by 10, which is the base, raised to power of -2, because after this point here, then this is the negative position, this is the positive positions. So we start from -1, -2. Here we start from -1, we start from +1 to moving on like that. That is why we have -2 there, -1 there, then point, then we start from 0, 1, 2, moving on. So I hope that is clear. So if you are given an example like this, you're told convert maybe 156 base 10 into the binary, because that is very important. How do you do that? That is the biggest question, and that is what we shall be doing. What we normally do when we are converting from decimal to binary, we normally divide this decimal number with the base of the number we are going to. So we are going to be dividing by base 2, and we continue like that until we get the least divisible number in that number system. We shall get to that. So let us go to the binary number system. And when we are talking about the binary number system, we say it has only two digits, which are 0 and 1, or on and off, respectively. This is very important. And that is why in the computer system, we normally use the binary numbering system, because it is very easy to represent using a series of switches, whereby where there is a signal, computers normally depend on electricity for them to perform. So whenever there is a signal or there is current flowing, then we can say that is a 1. Whenever there is no current flowing through that switch, then that is a 0. And it is very easy to represent that numbering system here. And so each single digit in a binary system is called a bit. When 4 bits are combined, then they form a nibble. Then 8 bits or 2 nibbles are going to form a byte, which is the smallest amount of data that can be held in a computer. So 8 bits are going to form a byte, 16 bits or 2 bytes are going to form a word, and then 32 bits or 2 words are called double word. And so we shall be seeing that as we move on. So this diagram here is showing the representation of binary numbers, showing that this is the highest bit, which creates a double word. One word is formed by having 16 bits. So the lowest bit is this one, because we normally count the bits moving from right towards left. Then 8 bits, they form a byte, and then 16 bits, they are going to form a word, and then 32 bits are going to form a double words. In between, we have a nibble here, which is 4 bits. So how do we convert these bits into base 10? Again, we will be multiplying these bits with their positional value. So it would be 1 multiplied by the base we are going to, 10 raised to the position value. For example, I could be talking of 1 multiplied by 10 raised to which power? Raised to power, this is 0, 1, 2, 3. So it is raised to power 3. And so that is where we will have the positional value raised to power 3. Maybe I could just put it like this. Then you add to 0 multiplied by 10 raised to power 2. Then we have 1 multiplied, this needed to be an addition. Add 1 raised to multiplied by 10 raised to power 1, and then you add it to 1 multiplied by 10 raised to power 0. So that is how you would normally do it. I tried to check the subscripts here. I can't be able to trace them quickly. So that is why I'm using, but they're usually found somewhere there, the subscripts and superscripts. So if I multiply 10 raised to power 3, that is going to be 100 plus 0 multiplied by any number is going to be 0. Then plus 10 raised to power 1, that is still going to be 10. So 10 times 1 is 10, and then 10 raised to power 0 is 1. So 1 multiplied by 1 is just 1. So it is 11. This is going to be 111. So just to show you how it is usually calculated. And this can be done on the other value just the same way. So that is how you usually convert from decimal or binary to decimal. Then we go to the octal numbering system. And when we are talking about the octal numbering system, it is where we have the number system having 8 digits. They normally range from 0 up to 7, and they can be converted as shown here. So this number system is very important because in programming, it has a similarity to the binary system, whereby you can have those 8 bits being a representation of a word, and that is why it becomes very important. Then, for example, if you want to convert this to decimal, then you are going to perform the same thing, whereby 2 is going to be in the position of 1, and 3 is going to be in the position of 0, and then you're multiplying it with the base where you're coming from. You will get the value And so even this one, you should be multiplying with the base where you're coming from, which should be 2. So the value here should be 2. Sorry. Then raised to power 3. Yes. The value here should be 2. Sorry. And so you will get it as 1 multiplied by 2 raised to power 3. 2 raised to power 3, that should be 8. And so it is 8 plus 0 plus 2 raised to power 1, that should still be 2. And so it is 8 plus 2 plus 1, which should be able to give you 11. So that should be 11 to base 10, and so on. So that is how we normally calculate it. And these are examples which have been used there. When we come to the hexadecimal numbering system, it is used for larger numbers, and we will see when we are working with the practical implementation. Hexadecimal numbers have the base 16, or there are 16 such digits where it begins from 0 and it goes up to E. The numbers 10 to 15 are denoted with the alphabets, where we are talking about A up to F. And it is also shown there how you can be able to convert. And so the BCD code, which stands for the binary coded decimal, it combines some of the characteristics of the binary numbering system and the decimal numbering system, such that the decimal digits 0 through to 9 are going to have a 4-bit binary code, whereby it uses the standard 8421 position weighting so that the pure binary code can be represented. And we shall also see that one, how it is usually executed. Then we also have the ASCII code, which is the American Standard Code for Information Interchange, and it is a special form of BCD code, which is now implemented in the computers and data communication equipment. This is the one we are going to be using when we are doing IP addressing. And the ASCII code is used to represent the 26 uppercase letters A to Z, and it is normally going to be used for the conversion of those numbers. So when it comes to IP addressing and subnetting, after we have understood the numbering system, then we can say that we normally talk of internet protocol addresses being the numerical label that is going to be assigned to every device or a node connected to the network. And this is for unique identification of this device or that host in the network, so that you can identify the location of the device in the network as well as uniquely identify that device or that host on the network. And then after assigning those IP addresses, there is also an activity which is called subnetting, whereby a portion of the network that shares a particular subnet of that class of IP addresses. So, like we have just seen with the numbering systems, where we have the different types of numbering systems from binary to decimal to hexadecimal and octal, then here is how they are normally used. Normally, human beings work with decimal numbers because they are easier than with binary numbers, which are needed by computers. Computers are going to understand the more binary numbers, but human beings understand the decimal numbers. Because they are easy to understand, binaries can bring about the errors when human beings are working with them. So an IP address, which is here we are referring to IP version 4, is going to be 32 bits. And those 32 bits are going to be broken up into 4 octets, whereby an octet has 8 bits. And so when they are 4, they are going to create uh, 32 bits. And here is an example of that, 172.64.126.52. That is an example of an IP version 4 address. And this IP version 4 address is going to be represented in terms of binary. Here it is in the decimal number system, and now in the binary number system we are going to have only zeros and ones, because we have said that binary numbering system represent values in terms of zeros and ones, whereby the number positions are going to be represented by increasing powers of 2. So let us see how it works. When we are looking at the binary number system, to most human beings, the number 124 represents 100 plus 20 plus 4. To the computer, this number is going to be 11111100, which is 64, whereby that is 2 to the power to the position number 6, 32, which is 2 raised to the position number 5, and 16, that is 2 raised to position number 4, 8, 2 raised to the position number 3, and 4, which is 2 raised to the power of 2, and then 0 and 0. That is the positional value. How do you count it? When you have these 8 digits or those 8 bits, this is going to be position number 0, position number 1, number 2, 3, 4, 5, 6. So that is how we have come up with this. So when you have 2 raised to power 6 is going to be 64. 2 raised to 5 is 32, and so on. That is how we are going to have that number. So each position in the binary number, it is represented starting from right to left. Like I told you, we normally count the numbers from right to left, and the power of 2, which starts with 0, and then it increases by 1 power as it moves towards left. That is 2 raised to 0, 1, 3, 4, like that. And so that is where you will need now to convert the binary to decimal and vice versa in order to compute the subsets and the hosts. So how do we do that? We know that, like in an octet, we are going to have 8 bits, and each bit can either be a 1 or a 0. And that is where now we start by understanding the ones and zeros. So if we have these ones, whereby we are going to have the entire octet having ones, what is going to happen? We are going therefore to have these ones starting from 0, the position of values 0, 1, 2, 3, 4, 5, 6, 7, and they are represented 2 raised to power 0 is going to be 1, 2 raised to 1, that is 2, 2 raised to 2 is 4, 8, 16, 32, 64, and to the power of 7, that is 128. And so this binary number, which is 111, all the bits are 1, then it totals to 255. So its decimal value is 255. And so that is why we are saying that the largest decimal number that can be stored in an IP address octet is 255. Now, this we will see as we continue to the IP addresses. So, how do we have the different IP addresses? We normally have the IP addresses divided into 5 classes, whereby each class is going to be designated by an alphabetic letter A to E. So class D, they are used for multicasting, and class E are reserved for testing and some future use, which is not yet known. That is why it is said to be mysterious, but it is for expansional future use. So I hope up to there we are together. So these are the classes. We will have the first octet, or they are based on dividing or splitting the first octet. So the first octet value, class A, will start from 0 up to 127. Class B will start from 128 up to 191. Class C address will start from 192 to 223. Class D will start from 224 to 239. And Class E is 240 to 255. So that's how the classes have been divided. Then, when we are talking about the ranges, you can determine the class of an address from its first octet. So if an address is going to start with 120, that is going to be a class A address. Why? Because we have said class A is going to start from 0 up to 127. If an IP address is like 155, that is class B. Why? Because we have said class B addresses start from 128 up to 191, and then if an address starts with 220 or even 192, that is a class C address, because we have said class C addresses begin from 192 up to 223. So hope that one is also clear. Then the 32 bits of the IP addresses are going to be divided